Okay, so the first thing you need to know about why chemicals form bonds why atoms form bonds with other atoms to make chemicals is the fact that most individual atoms, most single atoms, are actually very unhappy being single atoms. They're unhappy alone. But why are atoms unhappy by themselves? Why do they have this need to bond with other atoms? And what is a chemical bond? Um, Okay, so let's talk about, and this is the subject of this particular screencast, let's talk about what makes atoms happy and unhappy and how chemical bonds can make atoms that are unhappy happier. So remember, this is kind of like humans. Humans have a social need, and being in relationships with other humans makes us happier. It gives us something we need. Atoms, most atoms by themselves are unhappy because they are missing something that they need, which they can only get from other atoms. Now, when atoms bond together in groups, they form what are called chemicals. So here in uh, this sheet here, this is a picture of a bunch of atoms, which are represented by these circles of different sizes. And these atoms are kind of sticking together. They're staying very close to each other into this big group here. And this big group of atoms of different types is called sugar. This is a particular group of atoms that we call sugar. Sugar is a chemical. It's a group of bonded atoms. And all of these atoms have bonded with each other this way in order to make themselves happy, in order to get something they need. Okay, but what is it that atoms are getting? What is it they need? And why are they unhappy alone? Well, to answer that question, we have to look at the electrons. Remember, those are the negatively charged particles that orbit around the center of the atom. And when we look at electrons, so if we look at electrons spinning around the nucleus, in this illustration here, here's the nucleus, the center of the atom, which has the protons, the positive particles, and the neutrons, the neutral particles. And then we have these electrons, which are represented by the orange circles here. And electrons orbit around the center. They spin around the center of the atom. It's kind of like the way planets orbit the sun. And if you think about planets orbiting the sun, you may be aware that different planets in the solar system orbit at different distances. And they tend to keep their distance. So, for example, Earth orbits at 93 million miles from the sun. Venus is closer. It's closer to the sun and orbits more closely. Mars is further away from the sun and orbits at a further distance. But when the planets circle the sun, they tend to stay at those particular distances away from the sun. And just like planets stay at particular distances away from the sun that we call orbits, the electrons that spin around the nucleus of atoms, they tend to stay at particular distances from the center of the atom, from the nucleus. And we call those distances where you tend to find electrons. Those distances from the nucleus where the electrons tend to orbit, we call them orbits or orbitals or shells. So similar to planetary orbits. So here, what we see in this picture is this is the closest orbit. This is the closest the electrons are going to get to the nucleus. That's called the inner orbit. And then we also see electrons here in the second orbit, which is further away. And then more electrons in this third orbit, which is outside the second one. And these orbits are at particular distances from the nucleus of the atom. Well, one thing that's a little different between the orbits of electrons and the orbits of planets is that in a planetary orbit, you only find one major planet per orbit. Whereas electrons in their orbits, you can actually fit more than one electron into an orbit. How many electrons you can fit in an orbit kind of depends on the size of the orbit and how far away from the center it is. So, for example, in this inner orbit here, the close orbit, you can fit 2 electrons in that orbit. So this orbit is what's called filled when it has 2 electrons in it. That's the highest number of electrons you can have in that orbit. And then the second orbit, because it's a larger orbit, you can fit up to 8 electrons in that orbit. And then this next orbit also can fit up to 8 electrons. You might think it could fit more because it's a bigger orbit, but it's also further away, so there's kind of a weaker attraction between the electrons and the nucleus. Remember, what's keeping these electrons here is the attraction between their negative charge and the positive charges of the protons here. So the further away you get in an orbit, the weaker that attraction is. So there's kind of a balance here with the number of electrons in an orbit between how big the orbit is and how strong the attraction is between the electrons there and the nucleus. So in any case, you can fit up to 2 electrons in the inner orbit, up to 8 in the second, and also up to 8 in the third. All right, so we were talking about atoms that are happy or unhappy, right? So here's what makes an atom happy. What makes an atom happy is that any orbit it has that has at least 1 electron in it has to be filled with electrons. So if an atom has at least 1 electron in an orbit, it's going to need to fill that orbit in order to be happy. That is, to put as many electrons as it can into that orbit in order to get happy. And the other rule is that when atoms put electrons into orbits, they always fill the inner orbit first with electrons, and then if there are more electrons, they put those into the second orbit until that one's filled, and then if there are more, they put those into the third orbit until that one's filled. So depending on how many electrons an atom actually has, it's going to fill its orbits from the inner orbit to the second orbit to the third orbit and then further out until it runs out of electrons. So let's take a look at this particular atom. We won't name this atom, but we're just looking at the electrons here. Now, if you notice, this atom, if you count the total number of electrons in this atom, you find here 2 in the first orbit, 8 in the second, and then 2 in the third. So that's 8 plus 2 plus 2. That's 12 electrons total. So here's an atom with 12 electrons. And following the rules of electron orbits, it put the first 2 in the inner orbit, and then that filled up the inner orbit. Now it can't put any more in that one. And then it put the next 8 in the second orbit, and that filled up the second orbit, and so it can't fit any more into that one. And then the last 2 it had, because it still had 2 more, it put into the third orbit. Now the question is this atom happy in its state right here? Is this atom happy by itself? And the answer is no, because it has, this orbit is filled, and that's good, and this orbit is filled, and that's good, but what about this orbit? Well, this orbit has 2 electrons, but that orbit can actually hold 8 electrons. Remember, second and third orbits, they can hold 8 electrons. So this atom has 2 electrons in an orbit that can hold 8. So this atom is not happy. That makes the atom unhappy. So the rule of happiness is that atoms are unhappy when they haven't filled all their electron orbits with electrons. Or another way of saying that is an atom is unhappy until all the orbits that have at least 1 electron are completely filled. So here's an atom where there's an orbit that has 2 electrons and it ain't filled. So this atom is not happy. Okay, so what do unhappy atoms do? Well, unhappy atoms need electrons. What makes an atom unhappy is it's got electrons in an orbit, but the orbit isn't filled. So to get happy, that atom is going to have to get more electrons. Okay, well, how do atoms get more electrons? Well, they get them from other atoms. So in order to get electrons from another atom, this atom is going to have to engage with other atoms. It's going to have to interact with them to get the electrons it needs. And so in the next video, we're going to talk about how atoms engage with other atoms in order to get the electrons they need. Because when they do that, that is when they form bonds, chemical bonds with those atoms, and go from being single atoms to being chemicals.